Dr. Anthony Didlaike, an assistant professor of meteorology within the department, uses radar data and numerical models to understand the dynamics of tropical cyclones, from how they form to the changes in intensity and environmental interactions. One of our undergraduate students, Mike Susko, has more on this important research.
Mother Nature. Sometimes she is pleasant and shines bright. Sometimes she is cruel and destructive. Tropical cyclones and hurricanes are just one of the many types of weather phenomena Mother Nature has at her disposal, but they are one of the costliest. Numerous research projects are underway across the world looking into a tropical cyclone's structure and behavior. At the Penn State Department of Meteorology and Atmospheric Science, Dr. Anthony Didlaike, an assistant professor of meteorology, has been studying tropical cyclones for years, even having the chance to fly into Hurricane Carl back in 2010.
So my whole goal is to try to understand the interaction between the microphysics and the dynamics of the hurricane. So I'm trying to understand the hurricane from a cloud processes point of view.
One cloud process Dr. Didlaike examines is known as a secondary eye wall replacement cycle, a process that occurs when a storm sees a very vigorous change in storm intensity and size. One way to analyze this process is through observations collected from the storm.
The technology that we currently have gives us information about the wind structure and the microphysics. These are different radars that are either on the plane or in the land-based. So I depend heavily on the hurricane hunters to collect that data. I depend heavily on the regular NOAA operational radars. I also depend heavily on being able to run simulations, so numerical models using the weather research and forecast model. So I depend a lot on, of course, computational power as well.
Another tool for analyzing these storms is relatively new. Installed in 2012, radars across the United States received an upgrade featuring dual polarization. With this upgrade, radars can now provide scientists with information about a storm's vertical structure along with its horizontal structure.
And we've been able to take a lot of the dual polarization radar data to get a better understanding of the microphysics, the precipitation structure of tropical cyclones that has not been able to be observed in a tropical cyclone on a large scale before. So this is allowing us to look at the microphysics of a storm in a large scale for the first time.
With more upgrades come new data products to analyze and more questions for Dr. Didlaike and his team to answer.
Well, we're still trying to analyze a lot of the aircraft data that have been collected by the hurricane hunters in the past 15-20 years. So it takes a lot of effort to sift through the vast amounts of data, and it generally is not a very easy task. So there still is an opportunity to look at older data. At the same time, the hurricane hunters in NOAA, so we have two hurricane hunters. There's the Air Force and the NOAA hurricane hunters. The ones with the tail Doppler radar, they've recently upgraded their radar to have better sensitivity and better resolution. And so that's an opportunity in the future to get even more detailed information of the inner cores of tropical cyclones.
Tropical cyclone forecasts have been improving in accuracy and precision over the past few decades. Better supercomputers, higher resolution weather models, and better observations have all contributed to this improvement, but there is still more work to be done.
We still can improve in how well we forecast them. And so my research goes directly to that question.
If you are interested in learning more about Dr. Didlaike's research, you can find information on his website located at the bottom of your screen. While hurricanes and tropical cyclones are capable of complete and utter destruction, it is their unfathomable power that continues to fascinate Dr. Didlaike for all these years. For Weather World, I'm Mike Susko.